This is a recording of the George W. Ferris's Day Off. Let me read this paragraph here. Perhaps you have enjoyed riding on a Ferris wheel at an amusement park. The Ferris wheel was invented by George Washington Ferris for the 1893 World's Fair. Carlos, Clarita, and their friends are celebrating the end of the school year at a local amusement park. Carlos has always been afraid of heights, and now his friends have talked him into taking a ride on the amusement park Ferris wheel. As Carlos waits nervously in line, he has been able to gather some information about the wheel. By asking the ride operator, he found out that this wheel has a radius of 25 feet, and its center is 30 feet above the ground. With this information, Carlos is trying to figure out how high he will be at different positions on the wheel. How high will Carlos be when he's at the top of the wheel? To make things easier, think of this location as simply a point on the circumference of the wheel's circular path. So if the center line is at 30 feet and the radius is 25, then the highest point is 30 plus 25 or 55 feet. And the lowest point would be 30 feet minus 25, which would be 5 feet. And then on the left and right, it would be on the center line or 30 feet. Use the information about the Ferris wheel to find the height at each position on the wheel. The wheel has a radius of 25 feet, and its center is 30 feet above the ground. Because the wheel has 10 spokes, Carlos wonders if he can determine the height of the positions at the ends of each of the spokes as shown in the diagram. Carlos has just finished studying right triangle trigonometry and wonders if the knowledge can help him. How can you determine the height of the chair at point B? So what you're going to do is drop a perpendicular from point B to spoke A to make a right triangle. Where might you draw a right triangle in this diagram so you know something about its sides and angles? So once again, we're dropping this perpendicular from point B to spoke A to make a right triangle. What do you know for sure about the triangle we just drew? That it's a right triangle. The hypotenuse is 25 feet because that's the radius. And then this angle is 36 degrees because there's 10 spokes, and 360 degrees in a circle divided by 10 is 36 degrees. And then what trig ratio are we going to use? We're going to use sine, which is opposite over hypotenuse. So use the information by the Ferris wheel to find the height at each position on the wheel. The wheel has a radius of 25 feet, center at 30. Because the wheel has 10 spokes, Carlos wonders if he can determine the height of the position at ends of each. The spoke is shown in the diagram. Carlos has just finished studying right triangle trigonometry. She wonders if the knowledge can help him. So the thing you have to know is the math input boxes that I made on these slides are radian mode, so you have to convert each angle to radians in order to do the calculation. So if this is x, then the sine of 36 is the opposite, x over 25. Then x is equal to 25 sine of 36. And in radians, it would be 25 sine of 36 pi over 180. So changing 36 degrees to radians, 36 degrees is equal to 36 pi over 180 radians. So to find the height at B, you take the center line, which is 30, and then you're going to add this height here, which is 25 sine of 36 pi over 180. You get 44.6946. And then the height at C, so there's 2 spokes at C, so that's 72 degrees. And you're trying to find this height here. So you do 35 plus 25 sine 72 pi over 180. which is 53.7764 feet. And then if you look at the wheel, C and D have the same height, and B and E. So once we find B and C, we can find D. Same as C, and E is the same. This should be a decimal point here, not a comma. E is the same as B. And then F is the same as A. Those are both on the center line. Those are both 30 feet. And then I came down here to find J. I did 35 minus 25 sine of 36 pi over 180 because we're doing this length. So 30 minus this length would be J, 15.3054. And then when I look here, J and G are the same. So scroll up here, G, 15.3054 feet. And then to find I, we could drop this perpendicular here. Let me get the line segment tool. So this angle would be 72 right here. I'll use the pencil. So that angle from there to there is 72 degrees. So you do 30 minus 25, 72 pi over 180 is 6.22359, which is the same as H. Then on slide 4, if I were to graph this, so A, in order to graph sine or cosine, we're going to make a horizontal line at the maximum, which is 55, horizontal line at the minimum, which is 5, and then a horizontal line at the center line, which is 30. So we know that at position A, we're at 30 feet, and position A again, we're at 30 feet. And then at F, halfway between there, we're at 30 feet. So I get those 3 dots. And then halfway between these 2 dots, so if I go back to slide 3, the maximum is going to be halfway between C and D. So halfway between C and D, I'm going to put a maximum, and then halfway between H and I, I'm going to put a minimum one. And then you want to draw a smooth curve through there. That's a sine curve. If you look, it's sort of like a S on its side. So that's how I know it's a sine curve. The sine curve starts on the center line, in one period ends on the center line, and then halfway between on the center line, and a maximum and a minimum. All right, so here, the only thing we're changing is Carlos observes that it takes 20 seconds for the wheel to go around. So 2 seconds after passing position A, I know the whole way around the circle is 2 pi, so the circle, the Ferris wheel is rotating at 2 pi over 20 seconds. So it's 2 pi radians per 20 seconds, or pi radians per 10 seconds. So this is the rate at which is the wheel is turning, and then times the time. So we're going to have similar a formula as before, but we're using the rotational velocity and then times the time there. So 30 plus 25 sine 2 pi over 20 plus 2. And then 4 seconds later, that's at letter C. So 2 seconds, 4 seconds. So 20 seconds. If I divide that by 10, then each of these position letters would be 2 seconds. So 2 seconds away from A would be B, then 4 seconds away would be C, and so on. So at 6, you can just continue to plug into the formula, or you could look back at the slide we did with the angles, and you get the same answers. So and if you just type the word pi, you'll get the pi symbol. And then times 6. And that's 53, same as 4. So 4 and 6 seconds are at the same height. And then at 8 seconds, two pi over 20 times 8. So I get the keyboard here. And I get 44. And if I look up here, same as 2 seconds. So 2 seconds and 8 seconds are B and E, same height. 12 seconds. Well, 10 I did in class. That's right over here at F. I'll be at 30. And then so times 12 here. I got 15.304. That's this one. That's going to be same as 14, 16, 18. So 18 seconds, we'll get to there. Should have got the same answer. And then 14 seconds. Is 6.22359, same as H. And then 16 seconds should be the same height. So notice that these two are the same. In 18 seconds. That's the same as 12. And then finally 20 seconds. It should be back at 30 feet. All right, and it is so. So if we were to draw the graph of part 3, once again, let me do it in red. We want to put a dashed line. Whoops. Let me use the line segment tool so I can make this a little bit neater. So a dashed line at 55. And then a dashed line at 5. And then halfway between that, or the center line, would be 30. And then we're going to make our graph. So at 0 seconds, we're at 30. And then at 20 seconds, we're at 30. 10 seconds, at 30. And then at 5 seconds, we'd be at a maximum. And at 15 seconds, we'd be at a minimum. And then draw a curve through there. So we're going to try to draw a nice sine curve through there. All right, so this is going to be how we're going to write a formula or an equation for the sine or cosine curve. So we're dealing with sine right now. This could be the center line plus the radius sine 2 pi over the period times t. That's in radians or degrees. You just change the 2 pi to 360. The period is the time it takes for one revolution. So write the equation for slide 4. We already kind of did the equation when we calculated everything. So it's going to be h of t is equal to 30 plus 25 sine 2 pi over 180. And then times t. All right, so now you try here. This time the Ferris wheel's rate is 40. Center line is at 50. And it takes 30 seconds. So 3 seconds after position A, we're going to do the center line, which is 50. So 50 plus 40 sine 2 pi over, and then we know we needed to get the period here. It's 30 seconds. And then times 3. So 73.5114 feet, 6 seconds. I'm going to do the same idea, 50 plus 40 sine 2 pi over 30 times 6. And you get 88. You can continue to do that all the way down. All right, so once we find 3, it's going to be the same as 12. So this is 73.5555115. And then 15 seconds would be halfway around. So that's going to be on the center line, which is 50. And this all the way around back at 50. And then 18 seconds. So I get 26. So 18 seconds would be G. So 18, 21, 24. So it's going to be the same as 27. So 27 is going to be the same as 18. 26.4886. And then 21. And I get 11.955. So 15, 18, 21. This is going to be the same as 24. So I got the whole thing filled in now. For some reason, I don't have I meant to have a thing here, a graphic, so you could to get you started, but let me make this a little bit smaller so I can see. Yeah. So just a rough sketch here. So my center line would be at 50. And then up here at 90. And then down here would be 10. So at 0 seconds, then 30 seconds and 15. And then halfway between would be 7.5. And then down here, oops. Get the pencil now. So this would be 7.5. 15. 30. And then 15 plus 7.5 would be 22.5. And whoops. These would be seconds down here.
Try again? I think we got
Sure.
it.
All right. And this would be height over here.
Yeah, actually, give me 1 second. I'm going to do one quick thing here. Yeah,
And then the last slide here would be
oh, you
this formula. Yeah, well, I just making a recording, so
Oh, I'm sorry.
I'll be done in a second here. So it'd be h of t equals 50 plus 40 sine 2 pi over 30 and then times t.